Hi, good morning, everybody. We'd like to go ahead and get started so we end up on time. I'd like to welcome you to building AOL's high-performance, enterprise-based mail application using Silverlight 2.0. Let's start off with some introductions. My name is Eric Hoffman. I'm the director of AOL Mail Rich Internet Application Engineering back in Dulles, Virginia. I have with me today Mark Cachet, one of our lead engineers from the RIA team, Stefan Gall, our architect from the Mail RIA team, and Seth Halvax, product management from the Mail product team here. Our outline today, Mail RIA and Silverlight. We're trying to really define a new experience on the web. We're going to talk about what our RIA objectives were, just what our mission statement was when we went out at the onset of this project. Then I'm going to go through a little trilogy, a little tale of what we had to do to make the project come to life. I'm going to bring Mark Cachet up. He's going to talk about new user interface paradigms. Then Stefan Gall will get into some heavy nuts and bolts about the control work we had to do in order to bring this app to life. We'll finish up with Seth talking about monetization opportunities that this app provides us. And then at the very end, we'll have an invitation on how you can sign up to get this great new product that we are presenting today. So let's start with our RIA primitives. This is sort of what our mission statement was. Again, we really wanted to be defining the next chapter in web technology. We didn't want to be behind. We want to be actually defining it. Secondly, and probably most important, we wanted the application to be extremely performant. One of the big complaints we've gotten from members is that they love the features of our applications, but they're just not fast enough. And we wanted it to be rich and immersive. So when people are using the application, it feels good and they're engaged. Personalization taken to another level. This was another key factor we looked at. We wanted to be able to seamlessly switch between different experiences that resonate with different users without having to change a lot of code. Basically, we're using 95 to 100% of the code, just switching out the skins. And again, write it once, run it everywhere. That was a huge thing for us. We wanted to be able to write this code and have it run on all the popular browsers, and then as we found out yesterday, which was a great surprise to us, it's also going to run on mobile devices with very little changes to our core code, which is great efficiency from an engineering perspective. Again, beyond the web cache, I mean, one of the problems that we've struggled with web applications is that browser cache. Volatile data, you can't count on it. Is it there? Is it not there? With protected isolated storage, we know it's there and it's solid. With all these things, we have an enhanced engagement and new monetization opportunities. We'll cover that in a little bit later in the presentation. Let's start with our Silverlight tale. It began back in summer of 2007. Really, we were still working in Silverlight 1.0. It was JavaScript based, wasn't fast, but we saw a lot of potential. It had the great video and audio. It had compact size, and the idea of it running on all these browsers was very enticing to us. There was some DNA there for some controls, but just didn't have enough controls to really write an application. You could throw a video in there, had great audio, it looked great, but you couldn't do much else with it at the time. The .NET runtime was really appealing for our engineers. They loved C#. They were familiar with the environment. Again, another very attractive point. Challenge presented themselves. The 2.0, which was 1.1 at the time, Silverlight was delayed. The controls weren't there, but we were hopeful. This screen here is actually a photo, really pretty application. This is actually all written in Silverlight back in December of last year when we were working with some of the early beta bits from the Silverlight team. And as you can see, it looks like a folder tree and a mail list, but in actuality, all this is a series of stacks and grids with padded margins. The actual mail list is a series of horizontal stacks put in there. It's a lot of smoke and mirrors, but it was real data and it showed real potential, but wasn't real pretty to look at. But we were still hopeful. By the end of December, early January, Silverlight team was providing a lot of things we needed. The basic layout, stacks and grids, so the application would flow. Isolated storage was there. We needed that to cache data in an intelligent fashion, but size was still a factor. You only had 1 megabyte. Just wasn't enough space. Could we build an application on this? We weren't sure. A pivotal moment was reached. We had a couple of options. We considered a hybrid approach, mix the HTML with Silverlight. But we didn't like the idea of that, and we would love the compiled code. We were compiling the application. We were under 100K. We started adding JavaScript in it. It bloated quickly to 500 or 600K. So that quickly got tossed out the window. We said, well, we could delay the project several months. Well, that didn't fit well, too, because we wanted a great story from Mix, and we wanted to be first in the market defining the new chapter on the web. At the end of the day, we decided to write some code. This is a little code snippet that from one of my engineers on the team here. One of the controls we needed was very primitive. We didn't have a button, so we decided to write our own. You can see here we have a namespace, client controls.button. And importantly, I'd like to point out our abstract class is based on control, one of the most lowest primitives available in XAML today. By January 2008, we really needed more advanced controls. The app was coming together, but we needed things like buttons and checkboxes. We needed a real tree control, not the smoke and mirror ones I just showed you. We needed a list view that was virtualized to take a model that has a lot of data and stuff it on the screen in a very efficient fashion. We needed list boxes for setting. We needed to integrate HTML for compose and read. We needed grid splitters, custom layout. And we needed something very important, data binding, to move our data from our model into the controls. So by late January 2008, it really morphed into a collaborative effort between us and Microsoft. We were contributing to the core team at Silverlight. We requested functionality. We were able to validate the framework. Just some of the examples that we worked on with Microsoft that actually are in Silverlight 2.0 today because of the work we did. Encryption for secure isolated storage. Being mail data, we wanted that data to be encrypted and secure because we knew we were going to use that protected isolated storage. Imagine in a web application having background worker threads. One of the big things we've always been hammered on is single-threaded JavaScript. Well, that's all gone now. Now we have background worker threads. You can pull data while the user's clicking on UI. That was a huge breakthrough for us. And as we've been always talking about, cross-domain would be nice. We know that's going to come to fruition a little bit later on with some subsequent releases of Silverlight. That's important if you're pulling data off of an RSS feed and you're pulling mail data. So that's going to be key when we get that. Some of the examples of the code that we have for de-encryption. This is actually a little code snippet where we're actually pulling data out of the isolated storage. First, we decrypt it, we unzip it, and then we load the data, again, to make sure that the data is secure. Another example of some of the code we worked on with Microsoft. This is actually an example of where we have a main thread executing a save object function, and right below that, a nice new feature that we love in C#, an anonymous function delegates, where the actual thread code, the worker thread code, is right below it. And this is important because now I don't have to take this block of code and put it somewhere else. It happens in place. Very useful function. If you haven't used this is incredibly efficient. Makes your code size smaller as well. I'd like now to actually demo the application. I've sort of taken you through the story, talked about our primitives. I'd actually like to demo the application to you right now. This is actually our mail-rich internet application written all in Silverlight. This looks very similar to our current webmail experience. It has all the spam fighting, unlimited mail storage. But the big thing that we have on this application is performance. Again, this is live data coming off a server back in Dulles, Virginia. As I scroll through the folders, the data is just there. We take advantage of control templates for resizing. You can sort on the column headers, something you typically only see in a client-based application such as Outlook. Again, just to make it that much more convenient for our users. Again, on our contact list, as you see as I scroll down this, I can click on a contact, takes us into our compose experience. This is our standard offering, not that sexy, but one of the more powerful features we found out with this rich internet application is the use of control templates. And I'll take you into an experience now we found much more exciting. I click on a button, we switch the skins now, we're reloading the same application, 95% of the same code, just differences in art and control templates. This is our Halo 3 experience. Again, the same performance that we had before. I can scroll up and down the folders. The data is just there, thanks to intelligent uses of the protected isolated storage. Some other nuances we added to make the experience much richer. So I click on the settings dialog. Notice we use overlays here. Subtle transparency, storyboard animations. Little things like this make the app just feel a little richer. This is, again, going to be used for dialogues to alert the user if something's going on, maybe some settings. Again, in-place sorting, but it just looks and feels that much richer inside of this Halo skin that we put together. Compose experience, again, use of transparency and overlays. You see Master Chief in the background. The lightning, there's a good shot of the lightning here. Every 5 seconds we have a storyboard animation running. The lightning strikes on top of his gun. For those gamers out there, we're hoping this is going to be very compelling. And again, one of the things that was particularly interesting in this application was going into a foray of ultra-rich media ads. And as I roll over our ad, we use pretty much every trick in the book here. We have Master Chief putting his rifle away. We use animation with storyboards, irregular shaped windows, transparency, and overlays. And this is actually a clip from the game itself. So these are the kind of ads you're going to be seeing coming out of the skinning that we're going to be doing with our application. At this point, I'd like to turn the presentation over to Mark Cachet, lead engineer. He's actually going to talk about how we did this UI from a very technical perspective.
Thanks, Eric. Thank you. So Eric just, can you hear the mic? Eric just took us through how we got to this point in the product. Stefan and I are going to focus right now on what we did in the last 2.5 months, from when we went to that old picture he showed of the message list and the folder list as stack panels, to building the application with the skins that you see today and the code behind it. So one of the first steps was to look at the visual requirements of the application. We want to build an application that has the look and feel of a desktop app within the browser. So we wanted the app to be very appealing, to be rich in assets, to be very vibrant, to be very dynamic, to be sizable, to have elements in it that can grow and shrink, to be skinnable, very important, and most importantly, for the visuals to be fast and not to affect the business aspect of the application it should perform. And Stefan will talk a lot about like virtual lists and things like that we had to capitalize on to maintain performance. So in looking at building the application visually, there were two things. One, we needed to get a designer on board, and we needed to then employ our developers to utilize what the designers came up with and try to get them working. We had a designer on board, Steve, who's here today. Steve's job was basically to employ using standard tools like Expression Blend to building skins in its natural XAML format. On this slide here, we show two screenshots of the classic skin, which was his first pass at it. We had to make sure that we had an application that had the look and feel of the existing product. And we had him go a step further and build a skin that was several steps further in its complexity, which is the Halo skin that you see here. It was important that we think about multiple skins up front so that we can know and think constructively in the code behind as to what's required. So let me just backstep a second. There are a couple of things that I want to point out in the way Steve created these skins. These are single static pages that he provided to us, the developers. And if you look, he has elements in there that represent things like the mouse over color states, the selection states, and different elements of the application at different stages. It also, if you look at each skin, it also defines clearly key components of the application, which is what I'm going to talk about next. So from a development point of view now, we had to make his skin layout come alive. And the first step in doing that was to identify key components of the application. We had to get what was going to be in the root grid of the application well defined. And we call them components. And the components themselves are controls. On this slide, I put side by side what the components are. They're classified as panes there, side by side with the Halo app. And as you can see, there's a pane for the folders, there's a pane for the messages, and the toolbar, and so forth. So this was step one in trying to scope things out. Now that we have the root framework of the application well defined, we then had to go and populate each of the components. So the process here was to look at the skin, identify key elements of the skin, and try to wrap them up into controls, where the controls were visually going to paint those defined areas and also implement the behaviors behind them. Here on this slide, I note some of them. We had a data grid, for example, for the message list. The cells themselves in the data grid are controls in the message list. There's a list, there's a tree nodes, and a grid splitter. At this point, I could probably identify 3 key distinct areas in the controls. One are your typical visual controls, like buttons. The second would be like the grid splitter is a unique control in that it's a visual control like a button, but its inherent behavior in the code behind is actually to modify the layout of its siblings. So it's a visual control, but it has an extra task to it. And the third, it's not mentioned here, but we'll talk about it in a minute, are layout controls. And layout controls were important for keeping uniformity on certain aspects of the dynamics of the skin, and I'll show you that in a minute. Now, control templates were a key, Eric mentioned it several times, were key to the development of the product, especially when it came to skinning. All our controls derive from a Silverlight control class, which gives us control templates. And the key trigger here is that if we can group all control templates together, then we basically have a skin. So the basic foundation of a skin are its control templates, potential resources like PNGs here and there. We use very little of those, and other XAML resources, like the animation of the background in the Halo skin. I put a little code snippet here of the XAML for a control template. And by just looking at it, this could be a simple button that has two key UI elements, a rectangle and a text block, where the rectangle could be the highlight rectangle, as it's noted there, and a text UI element for its text. Also included there is just a snippet of some resources that could be in the control template. In this case, a storyboard for a mouse enter. Picture, if you could, that the code behind for this control template could discover that storyboard. It could be hooked up to a mouse enter event, and it could be that animation could be triggered. So that could be how a particular button in the UI could react to a mouse over event. Something to note here also is that the two UI elements in there, the rectangular text block, could have been UI elements that were extracted from the skin that I showed prior, like the Halo skin or the standard skin, and could have been extracted from there and inserted in here. And there you have the layout of that particular control. This is some code behind for the instantiation of a button cell, for example, in the data grid. The reason I have this here is to note that one of the tricks towards getting our skins dynamically changed was to have the control templates dynamically discovered. So we have a resource helper class that we built that will, at runtime, go and discover the XAML for that particular element from that particular resource for that skin, extract it, and dynamically apply it on instantiation. So that's what's there. One of the challenges we had with the skin was skin motion. As we know, the browser resizes. We included grid splitters in the data grid and in between panes in the UI to allow the application to resize. But it created some problems for us. And Steve, when he was building the skins, asked if he could be as flexible as he can in the way he drew, for example, the Halo skin as compared to the classic skin. If he could be flexible with some of the background. And if we look at the Halo skin, we can see that when I mouse over the grid splitter here and I move it, there's uniformity in the background frame of the two panes, the left pane and the middle pane there. So that posed a challenge for us. And the challenge was that when we write the code, we don't want any code in the business side of the application to have any knowledge of any skin. The skin it should be completely clueless of what skin it has. So that problem solved itself by building layout controls. So in our case, for example, I needed to change layout where elements basically size themselves to the allowable size of the parent. So in this example, you can see that I wrapped up a path and a rectangle in a custom control called a view panel. And in the next slide here, this is the definition of a view panel. It derives from a Silverlight panel, which allows children. And we just simply implement and override the the measure override and a range override functions. And these are two methods where you can iterate through the children and adjust their position. So in our case, we did exactly what we needed to do. This solved the problem. In the Halo skin, it uses the view panel. In the classic skin, it doesn't, as there's nothing to manage in that simple skin. In Visual Studio, the skin is essentially a project. In this, I don't know if you can read that. There are two projects in there. There's a standard project and a Halo project. And as you can see, the skin is essentially a collection of templates there. The templates folder is all the XAML. Resources is XAML, and any optional images. Most of the iconic-looking graphics in the product they're all XAML. We use very little to no PNGs. To support skins, I showed you the resource helper class that we used earlier. That helps us load and unload skins, helps us locate resources in the skin, and helps us discover certain things like potential background animations, which, like the header component in the application, for example, will discover. If it exists, we'll invoke it. So in summary, from a visual perspective, we feel we have a skin solution. I showed you we have separate assemblies for the skins. It should be noted that you only need one skin assembly at startup. Other skins are discovered and downloaded at will. We have a well-defined layer for designers to work with. So Expression Blend will now have template editing and so forth. So now the method by which we initially built the first two skins, the next step would be to just have the designer work exclusively with the whole solution and be able to build a skin in the well-defined control templates that we have right now. Stefan will now talk in more detail about the controls. I just laid them out from an overview perspective, and Stefan will also talk about virtualization and observable collections and so forth. Thank you.
Thank you, Mark. So in our quest for high-performance, rich, interactive application, had to do quite a lot. As you have already seen, both Eric and Mark mentioned it, about a couple of months ago, we were not even close to where we are now. Basically, at that point, we had a WPF prototype that was doing most of the business logic. It was proven. The UI was obviously significantly different. It was just a proof of concept. At that point, we decided, as Eric mentioned, that the best way to proceed is to write custom controls. As you can imagine, there were many things to do. I will try to focus today on two aspects that I hope to be useful in your development of rich internet applications. And I will focus next on our experience in developing custom controls and Silverlight overlays. I will define the overlays, well, our definition of it as we get there. With the custom controls, Mark has already mentioned some of the goals. The goal number one was high performance. For us, performance was extremely important, continues to be extremely important. The other goal was extreme flexibility. And what do I mean by that? Let's think, for instance, of a tree. You have data in the shape of a tree. You have objects that have children, hierarchical. That's generally data in the shape of a tree. We didn't want to lock the designer into any particular representation of that tree. So we wanted to separate, this is the data, this is the business logic for a tree. A tree can expand leaves, can collapse leaves, can select leaves, but you didn't want to lock in the business logic or the control logic any particular representation. So we have 3 layers there, which I will talk about later. Mark has already mentioned that all our controls are skinnable. It was from the beginning a target. And last but not least, we have to keep in mind this is still an internet application. The code size is important. Eventually, the code needs to be downloaded to be able to run it on the user's computer. It was mentioned several times. I will mention it again. Using control templates helped us a lot, and it provides a lot of power. All our controls are template-based. In order to achieve the separation we were looking for and also the performance we were looking for, we made extensive use of data binding. Also, whenever it was possible, we used template binding. It kind of arrived late in the game, but we still used it. Another important aspect that we concluded that helps a lot is having shared resources and shared styles. Imagine, for instance, a brush that's used throughout the application. You have the option, and the visual effect is the same, to define it again and again and again in every part that uses it, or define it once as a resource and reuse it. The code is lighter, more maintainable if you reuse your resources. Another important lesson that we learned is virtualizing the controls. In our application in particular, we have large data sets, contacts, message lists. People can have thousands or tens of thousands of items in those data sets. I will address that going further. Now, this is nothing new, but in order to have our data observable and to be able to take advantage of data binding, all our objects, data objects from the model, implement this pattern. So they all implement the iNotify property change the interface so that we can take advantage of data binding. Also, all our collections are observable. So we use the observable collection, which, as I will show later, we can take advantage of virtualization and the built-in support for observing it. We wrote many controls. I would like to focus on one of them, which, again, is not currently, it's not currently part of the SDK. It could be argued that the data grid is, but the data grid is much heavier than what we needed. And that is the virtualized list. What it does, it basically takes 2 inputs, is the collection of data and an item template. So the list itself doesn't know anything about what the data is or how it should be represented. Those are inputs. All it knows that it has a collection of data and it has an item template that defines the visuals of the item. The business logic, the role of the list itself is to decide how those item templates are laid out. In this particular case, a list, it's expected to be vertical stack. Obviously, that could be a horizontal stack, it could be a grid, it could be any layout you want. So the control itself manages that. How would it look in markup? You have the list, defines the item template. In this particular case, it just configures one of the pre-existing elements, a list item, and customizes the foreground, as you can see, to blue, binds the caption property of the data object to the text to be displayed. This reuses the list item, which has all sorts of mouse in, mouse out, clicks, selection, but you don't have to do that. If you want to start it from the ground up, you can do something like this, where you define the template from the ground up. It's exactly what you want to be. As you can see, and I mentioned earlier, the list doesn't know anything about the data and the template. There is a contract, however, in between the shape of the data and the item template. The template, as you can see, can, in order to be able to extract the data, has to know what properties are there and what do they mean. But that is strictly a contract between the data and the template. The list itself can cover, and we used it in a number of cases for different data shapes, for different item templates. OK. Let me show you now, if I can wake up my computer, how it actually behaves. And I didn't address yet the virtualization aspect of it. It's going to be obvious here. What I have here is 4 such lists. It's 1, 2, 3, 4, that all bind to the same data source. So as the data source is modified, you can see the visual representation of the items on the screen. For instance, adding content, as you can see, they are all added, scrolls, so the data binding works beautifully there. Virtualization is nothing new, but it really helps us a lot. And the way we made it work here is we create precisely as many DOM elements, visual tree elements, as you see on the screen. So you may have much more data items. But the visual tree that corresponds to it is exactly what you see on the screen. The best way to look at it is, for instance, by adding 1,000 elements. That's basically how fast it is, and that creates 1,000 elements, inserts them in the list, notifies each of the 4 lists that an item was inserted, and it is that fast. Look, for instance, at the scroll performance. It's seamless. It behaves like there are 20 elements, and that's exactly what it should do. It doesn't care there are 1,000. The DOM behind is light, the stress on the CLR is light, the experience is good. Let's push it a step farther and insert 100,000 elements. It's all done. It goes up to 100,000. And it scrolls seamlessly, it's light, there is no impact on the UI stress on Silverlight or on the CLR. Let me get back. Yes. On the next topic, which is the Silverlight overlays. Could be considered something specific to our application, but I think it will help many. Let me explain first why we needed it. Being a mail application, obviously, we need to be able to render HTML. Render as well as compose. And the way to do it, we are hosted by a browser. We use the browser to do it. And as you can see here, the rectangle behind is the main Silverlight plugin. We use the div or an iframe to render that HTML. And we position that HTML, absolute position it, on top of the Silverlight plugin. That works seamlessly. Well, we'll show you later. Let's see first about the overlays itself. The challenge this creates is, if you need to render anything on top of that HTML, Silverlight cannot do it. Silverlight is below it. And the way to do it, you need to create another Silverlight instance that you have to position on top of the HTML. So you have a sandwich of Silverlight, HTML, another Silverlight instance. So you you gain HTML rendering, but you have this headache of managing another plugin. As I mentioned, this is basically why we needed to do it, and I would assume most applications would have to do it. Being a web application, many approaches would have to manage one way or another HTML. So we used these overlays for context menus, modal dialogues, rich tooltips, out-of-banner Silverlight ads. You have already seen that. And last but not least, legacy ads. What challenges did we have? First of all, from within Silverlight, you need to create another Silverlight instance. Secondly, we needed to communicate between those plugins, and it's not as simple as it seems. Thirdly, we needed to share code and resources between the two virtual applications and manage the lifetime of additional plugins. Creating it was fairly easy after some research. Basically, we followed the same approach as we followed with the HTML div. Just create another host element, a div element, and we used the support provided by Silverlight.js to create another instance. We used the second plugin, the overlay plugin, in windowless mode, such that it supports transparency, irregularly shaped windows, and it provides a seamless integration. It seems like it's part of the application. They work well together. The code is here. If you ever have to do it, I think it will be useful. Something that should be noted is we use the init parameters such that the overlay plugin has enough information to be able to reach back to the main plugin. They need to be able to communicate and hook up to each other. As I mentioned, the communication between plugins turned out to not be as easy as we hoped. And that is because the two plugins have different application domains. They function like two different applications. They know nothing about each other. To resolve that problem, we used JSON to provide the input parameters and to return the output results. Passing JSON, obviously, both input and output are passed by value. We have a way to communicate live between the two using scriptable objects. So if you need to ask the main plugin to do something while the overlay plugin is up, we have a way to do that. And that is using scriptable objects. One of the challenges that we also had to overcome was the asynchronous nature of the process. As you can imagine, being two different applications, you create a second plugin, but you don't know when it's ready to talk to. And there isn't a loaded event when you talk to the control, but that loaded event fires well before the application object is created. So in order to resolve that problem, as I mentioned earlier, we passed the plugin ID as an init parameter to the overlay plugin, and the overlay plugin, when it's ready, and the application instance is created, reaches back into the DOM and talks to the main plugin. Sharing code and resources. Okay, I will get back to that slide after explaining what I mean by sharing code and resources. So basically, we have two different applications. And it's very likely that the overlay plugin, or the pop-up application as depicted here, would need to reuse some of the controls or the logic or the resources available in the main plugin. You have the option to deploy it twice, include the controls in both application packages, but that would be inefficient. Then it needs to be downloaded twice, loaded twice, managed twice. what we decided to do instead is load those assemblies, the assemblies from the main archive, dynamically. It's not as bad as it seems, because at that point, the main application package is already cached by the browser. It's being run by the browser. All you need to do is reach into it, load the assembly dynamically. How did we do that? Again, the code is, well, the relevant snippets of the code are here. So if you ever have to do it, it works, and it's extremely useful. The way it looks like, it looks like the code is basically downloading the package and reaching into it, extracting the piece, and loading it dynamically. But because that archive, the main archive, is already cached by the browser, it's fast. Well, again, the pieces I mentioned about. Let me show you some of those overlays in action. I think I'm C. Yeah. For instance, Eric has already showed you, this is one of the overlays. So it's basically as you can see, this is HTML. So that's not Silverlight. This is Silverlight. So for composition, we are using an iframe and overlay an HTML, as an HTML element. For instance, this one needs to go on the HTML over the HTML element. This is an overlay. And as you can see, integration is seamless. It doesn't feel like a different application. It is a different application, but it's integrated so that it doesn't feel like one. Again, this one is another overlay. This is another overlay. And we used it over and over again. And obviously, as I mentioned, for rich ads, this also goes on top of HTML. So it's a Silverlight overlay. As you can notice, it's semi-transparent. It's irregularly shaped windows. So all the goals you were looking for are met. Let me introduce now our mail product manager, Seth Holvax. Yes. It's C or D. D.
Great. Thank you, Stefan. Saving the best for last, of course. Sorry about my voice. I had a little too much fun last night playing craps, so it's a lot of yelling and shouting for those of you that like to play. Well, you heard a lot about how to build your own rich internet application. These guys did a hell of a job. We'll talk a little bit about monetizing our traffic. So to start with, I wanted to revisit the objectives that you've heard each of these guys touch on in their presentation. First of all, we wanted to build a very engaging and interactive application. It was very important to us to make sure everything added value to the user experience, especially the advertising. Second, performance. We were very focused on performance. We wanted to maintain a very high standard of performance. And we believe we've done that. Third, standards. Especially as they relate to advertising, standards are very important. So using the IAB, UAP standard ads where we can was part of our objective. Integration between ads and the application, you've probably heard that several times in the keynote and here today, but it was very important. And two things. One thing that meant was making sure the ad felt like a part of the application. It wasn't something that was just at the top that users learned to ignore. But second, that the content was also relevant to the user's experience. And the skins were one way we were able to do that, or one way we are able to do that. When a user selects a skin, we can then provide an ad that is targeted to a user with a gamer-type profile, as well as providing content in the panels that is interesting to this Halo-related content in this case. and that includes high-definition video, such as a game trailer. And what this means, of course, more interaction with the application means a higher click-through rate and means higher value for our advertisers. There are a number of rich media options that we believe will help our advertisers build rich, immersive campaigns. And you've seen this several times at the ad. I won't flip back over to it again. But it has the video on video. It has the expandable banner starting from the 728 by 90. Once it expands, it has the irregularly shaped windows and the transparency, the rich animation, and also audio, which I didn't play here, but there's audio there as well. So I only had 2 slides, or 3 slides. In summary, we feel that Silverlight has helped us build a new experience on the web with industry-leading performance, unique skinning and personalization opportunities, and high-impact content delivery. Users can get the content they want, including high-definition content. In the case of the mail application, we provide the convenience of webmail, a web-based email product with the performance of a desktop application. And this is one of the examples of the innovative products that you'll continue to see from Mail from AOL, where you can get the email identity and the experience that expresses who you are and what you like. So with that, we'd invite you to sign up today to be notified when the preview is available. You can go to ria.mail.aol.com. With that, I'll hand it back to Eric.
Thank you, Seth. So we've covered a lot today, but at the end of the day, what I want you folks to remember is where we ended up. It's a hard journey. A lot of technology went into it, a lot of ups and downs. But at the end of the day, what we're going to do is we're going to marry together what AOL has core strengths on, our world-class spam fighting, unlimited storage, with cutting-edge technology. So where do we take the app from here? Probably by April, we're going to have a preview and a beta available of this product with basically 2 skins. By the time Silverlight 2.0 actually goes live in the summer, we'll hope to have more skins defined. And then allow users to actually define their own skins. Again, more personalization. Hopefully it will resonate with them and more engagement. So I invite you to sign up for this application. Give it a test drive. We're really waiting for this thing to be solid when it comes out. Fewer features, faster performance, and rock-solid stability. That's what we're shooting for coming this April. So give it a spin. Thank you. Any questions, we'd be happy to field those now.
Yeah, I'm just wondering whether you considered using Flash instead of Silverlight, and if not, what were the differentiators that persuaded you to go with Microsoft's technology?
So, there's a lot of different technologies that are available in the RIA space at the current time. And AOL, basically in different groups, there's different uses of different technology. But for the mail group, this technology just fit for us for a number of reasons. We've been partnered with Microsoft in the technology adoption program for over a year and a half now. They were a good business partner, and they were willing to work with us to help define what Silverlight was for our needs as an application. So for us, it was just the right fit. It also resonated well with our engineers, the familiarity of .NET, the runtime, Visual Studio. And then we mixed in with that the designer-developer paradigm that works very well for us. So it wasn't just about X versus Y. It was about all 4 of those facets, and that's why we made the decision to go with it for our group.
You mentioned a couple of times you spent about 2 months developing the application. Do you have a sense of the number of developers and the man hours that it took to develop it?
I'm sorry, can you repeat your question? I couldn't quite hear you.
You mentioned a couple of times that you spent about 2 months putting this together. Do you have a sense of the size of the development team and the number of man hours that it took to kind of get to this point?
Yeah, it really was we full-time for about 2 months. I have a team of there's 6 of us essentially that worked on it. And it really is much more rapid than what we saw in DHTML, especially with the skinning. So it's, you can create an application like this with a good team of 5 or 6 engineers in several months if you got rockstar engineers, which fortunately I do.
You showed an example of the virtual view of how fast that was, but I wasn't clear of what's the first-time experience. If you've got 1,000 mails in your inbox, are you having to go request all of those before you can actually build that virtual view? Or?
That's a great question. So, the first time, you have to get the data. You got to get the data at least one time, and then we really rely on that intelligent caching with the isolated storage. So the very first experience is we got to get the data. But what we do is we fill the screen immediately with enough to fill the actual mail list. And then we're pulling data in the background. But by that time, the data's already pulled. So it's a little sleight of hand, but the user doesn't really see it. So, I mean, it actually worked out well for us. And with the technology that's here, it's a much better first experience that we have with our DHTML-based prototypes.
I have a couple questions. The first one is you mentioned protected isolated storage a couple times. I was wondering if you could elaborate on what that means. I'm curious if that's client-side storage.
It is actually client-side storage. So what Silverlight has given us, which is very attractive to us, is a portal into the desktop machine, onto the hard drive. It's accessible through a series of APIs that allows us to store actual data. In this case, we store folders, mail messages, summaries of mail messages on the hard drive in an XML format that's been encrypted and compressed.
How much data can you store on the hard drive? Or are you
well,
limited
when we
to-
started, as I mentioned this in the presentation, when we started, it was set at 1 megabyte. So, but now, with a prompt, you can actually expand that. I mean, we're on this application here, we're actually running 10 megabytes of protected isolated storage. You got to prompt the user, though. So the user will be prompted, hey, would you like to have a better offline experience, loosely connected thing? You can expand the storage. If they say, okay, you can do 20, 30, 40, 50 megabytes. So you can cache, it can be unlimited. I mean, it's really based on hard drive storage, but when we launch this, we're probably going to go out with something in the order of 20 to 50 megabytes. So we can cache, large address books, folders. If you're a heavy mail user, you may have 10,000 mail messages.
Is it persistent? Is it
per session, or if you close the browser, does this go away? Or?
No, it's persistent. It's actually persistent. So if you close the browser and fire it back up, it's only that one-time first initial hit you get. That's the beauty of it. And it's not like you're going to go clear a browser cache, which I mentioned before. That data is so volatile. In this one, it's a lot more protected, hence the word protected storage. It works out well.
You're keeping it in sync between the server and the client. That way, if they hop to a different desktop, they'll download it again and then store it on that computer.
Exactly. It gives you the ubiquity that you're looking for. You can go. You have to download that cache again, but once you have it on the machine, we're habitual. We tend to use the same machine over and over again. But if you are in a coffee shop and you get on one of their machines, it'll rebuild that cache for you on the machine.
My second question had to do with so in the traditional AJAX mail system that you have, there's probably a mountain of JavaScript that is your framework for, and you have to probably spend a lot of time dealing with interoperability issues between different browsers. And I'm wondering if Silverlight solves that issue, or do you still have a lot of interoperability problems?
Honestly, it does. I mean, there's small nuances between Firefox and IE, particularly in the area of the compose and read. But by and large, 95 to 96% of the code is write it once, run it everywhere. We focused, since we're an early adopter, we focused on IE in Firefox, but it's significantly better than our experiences with AJAX, significantly. So it's just one less problem you have to worry about as a development manager.
With the Olympics being in Silverlight, are there plans to do custom skins for the different sports that the user could personalize?
I'm sorry, I couldn't quite hear your question, ma'am.
With the Olympics being in Silverlight, are there plans to do custom skins for the different sports that a user could personalize?
Sure. So, I mean, our skinning strategy is going to be, as I mentioned before, we're going to come out with an initial set of skins for the preview and beta. But then eventually later on this year, people are going to be able to define their own skins. So, I mean, that's really where we want to take the product. Whereas we don't know what resonates with all groups of users, and you can't because you have limited resources. So, let users define their own skins, and hopefully that'll drive some more engagement for us.
Go ahead. No, go ahead.
Defining your own skin, you mean a user has to have Expression Studio to define his own skin? Well,
we make. We're sort of still in the planning stages of that. We may give them a framework, and then within that framework, they can choose different pieces of art, maybe different vector graphics. We give them a template to start with, because that'd be, it depends on their skill level. If they're obviously an engineer or something like that, they could do it from scratch. But we're probably going to be somewhere more in the middle where we give them a template. All the framework is there, and they can define. They'll have a choice of different colors, different art they can swap in and out.
It's all inside AOL, right?
I'm sorry?
It's going to be all inside AOL Silverlight application.
Yes, we're going to have a support website that'll allow them to go to it and choose these different things, and then it'll actually download that skin as a separate, we call a ZAP file. So that's every skin that we have here is going to have its own separate ZAP file downloaded when it's needed.
Thanks.
And you'll be able to share those as well, too. It's a great point. So once people post them, we'll have a site where people can share these and download them and modify them and get a little, organic kind of, sharing thing going on. That's our intention at this point.
So you guys got a lot of IP. How do you guys plan on protecting it? Can somebody just go to the website and download the zap file and take it apart and look at your encryption keys?
That's a great point. So there's this little thing there's a little thing called a code obfuscator. I'm sure you've heard of it. So that's one of the things we're looking at doing before we actually put this out for preview. So I mean, yeah, you have to, you've got to be cognizant of that. But at the end of the day, if people are that passionate about our code, that's a great compliment. That's a good problem to have. But that's what we intended. That's a good question. That's what we intend to do to protect that.
How does browser navigation affect your app?
And specifically,
like the back button, the forward button, because we saw with Ajax with IE8 actually working, but how does it work with Silverlight?
So it actually works the same way. I mean, I'm going back right now to the, as I show you, it goes right back to the application. So we really, at this point, we really haven't had too many issues with it. It works basically the same way it does in Ajax. Okay. It's just, we haven't had too many issues with it, I guess, is the short answer.
Thank you.
Mm-hmm.
How are you dealing with deltas of change between the client and the server? Say I hit AOL AIM on the web without the Silverlight app, make some changes in my contact list. How are you dealing with the client the next time it opens up and refreshing that contact list?
So we have, it really depends, it's a complicated answer. It depends on where in the application the data changes. If it's mail data, we have a very intelligent system for getting only new messages. If it's a whole new skin, then we have a schema for that. I mean, I guess we don't have one answer for, we have several different answers for different parts of the application, varying in complexity from very simple and rudimentary to very complicated to only, I mean, we're really trying to be very careful about how much data we pull down to keep the app very lightweight and very quick. Especially with the skins, like I said, and even in the application, what we do is we only load, we have everything in a separate zap file. So we only load what we need when we need it. And that's just to maximize getting things up and getting things running. So that's the strategy we're going to, and it really works for us. So for example, to get the app running, maybe we only need the zap for this, but we don't need the zap file for the compose and read experience. We download those later when we need them. So that's how, that sort of model is roughly how we're going to handle updates if you get a large amount of new mail data, so on and so forth. That makes sense.
All these code snippets you showed today will be available for download, right, in this PowerPoint presentation?
Yeah, the PowerPoint will be posted today. I just handed it to Microsoft guy right before the presentation, so it will be available for download, absolutely.
Yeah, I have a question related to the 508 compliance. Do you guys need to support the 508 compliance?
I'm sorry, I couldn't understand the question.
508, like accessibility, usability, like
accessibility. Accessibility is an interesting question for us. We intend to make it as accessible as we can with simple things for the first release, which will be things like keyboard shortcuts, things of that nature, tabbing. We plan on doing some of that, but it probably won't be fully accessible for the preview in beta. But eventually, we will look into that. And I know that that's a challenge that, and one of the things we're working with Microsoft right now is to make Silverlight more accessible, so that you can use things like JAWS screen readers and things of that nature. And I know they're working on that, but I don't think it's part of the first release. I'm looking at one of my Microsoft colleagues here. It's not part of the first release this summer, but that is something I think they're working on for next year. Good question.
I just had a question about the way you did your overlays. Why is it that you actually had to do that? Because it seems like you had to, what you did is fantastic.
Thank you.
Oh, absolutely. So just from, I was looking at the controls that are supplied today, and I noticed that there was a pop-up control. I know that you can take user controls and hide this one and show that one. So I was just trying to figure out
why. The question is why we do it.
Well, I know you have a good reason, so that's why I'm asking.
Yeah. So to be honest, we ran into a couple of problems. The one problem we had is in our application, which is unique to some of the others, we actually have to mix HTML and Silverlight on the screen at the same time. For example, if I read a message here, I'm in the read experience now. That has actually got an iframe running HTML on it, where it says, my name, mail development manager, my phone number, stuff like that. Well, what we ran into was an interesting focus problem between Silverlight and HTML. So, and in fact, we had a problem where they actually had focus at exactly the same time. So you'd be typing, and it would type in both areas at the same time. So we had to use overlays to overcome the inability for them to live harmoniously on the screen at the same time.
And
that was one of the primary drivers behind having the overlays, is that we wanted to be able to have this ad now as I roll over it. So now that's overlaid over top of HTML. If it was just Silverlight, the problem would have been much simpler. If we just had it over top of our message list, in this case here, we didn't have that focus issue. And then Stefan has a lot more detail on it.
What I wanted to add, it's a good question, very good question. We would have liked to not have to do it.
Okay.
And there is a pop-up control, but unfortunately that lives only within Silverlight. If you have a div overlay on top of it, you don't see it. It stays under.
And then you start getting a Z-order problem.
Exactly. Well, it's not bad. So because we put something on top of the main plugin, we are by ourselves. That tooltip doesn't work anymore, and pop-up doesn't work anymore.
And you can't write in the adorner layer? Does Silverlight have an adorner layer?
There is a Z index, but that Z index is within Silverlight. It has no idea that there is something on top of it.
Now I'm speaking about the adorner layer now. Is there an adorner layer like in WPF and Silverlight? They don't have an adorner layer that you can write into? No. Okay, because I know that they're supporting the iData error info data binding, and they talked about that. And so the way the controls work is that by default, if a control has a data binding error, it puts a little red box in the adorner layer, right, around that particular UI control. And so, I mean, that's how WPF works. And now they've stated that Silverlight will now, it'll support that interface, that text box and their data binding mechanisms will support the same way it does in WPF. It'll be comparable in Silverlight. So I was just wondering, that means that they have an adorner layer that we can now play with, because you can put anything in the adorner layer.
It's really about rendering.
Okay.
I mean, regardless what you support.
Okay.
I mean, if there is something on top of it, it cannot render above it. You need something to put something on top of it to be able to render anything on top of HTML.
Yeah, and the truth is, this stuff's still changing. I mean, the controls that are available that we saw in the keynote yesterday weren't available to us even 3 weeks ago. So,
and see, that's why I'm asking also.
Yeah, so, I mean, what's true when we built this may not be true even a week from now. We're still getting drops. I mean, there's going to be another drop of Silverlight in April. So, and we're still working with them on changing some of these things. So some of these things you may not have to do by the time it goes live. Yeah. So that's one of the curses of being an earlier adopter. But it was fun. I got to say, it was a lot of fun.
No, it's a fantastic application that you guys have. So this in your HTML editor. So when you bring that up, you're putting an iframe.
Yes.
And the iframe is the entire thing?
No, it's just actually, if I could, just the editor itself. The point that's like the translucent white, that's the iframe. This portion here, where I'm typing, this is actually Silverlight.
Okay.
So basically everything below right here, this is the iframe right here. This is just Silverlight controls that we built right here.
Did you try the window browser control for that?
I'm sorry?
There's a window browser control, according to the poster.
Yeah, well, we stuck with the iframe for a couple of reasons, so that it would work in all the browsers, and we just set some flags for edit versus non-edit. So that's why we stuck with the iframe, because divs. Correct me if I'm wrong, Stefan, but the divs don't work in Firefox for editing. So you could read, but you couldn't do any compose. So that's why we had to keep it at the lowest common denominator for that experience. Yeah.
So you put an iframe in there that's inside your Silverlight code?
That's correct.
And what control did you use to expose an iframe?
Go ahead, Stefan.
So we didn't use a control. Basically, we reached directly to the DOM and manipulated DOM. Create.
Right.
Yeah.
And that's how you did it?
Yes.
Okay, real simple.
Yeah.
Right. Okay. Thank you.
Sure, absolutely. Any other questions? Thank you. Give it a try.